Okay, so here, our next demo is this string here. It's a sine wave generator. So it makes transverse waves. So transverse waves do what? They go like this, or do they go like this? One or two? Two. They're transverse, so it's going to move up and down. So here, I have this generator here. I'm going to mount it up here. For now. There it goes. Alright. And right now I have it attached to a couple of things, but the speaker is not attached. So don't worry about that guy yet. But what I am going to do is I'm going to run the power to this guy right here. And what he's going to do is he has this metal tab here, and it's going to move up and down, okay? And it's going to create transverse waves in this string, okay? So remember when y'all did that Slinky lab, that you moved it back and forth to make these transverse waves. Well then, in part C of that lab, you were required to make standing waves. What's a standing wave? You may remember? Well, then it sounds like this is important. So a standing wave is where you generate waves that interfere with each other constructively and destructively to create a pattern that you see over and over again. So it makes it look like the wave isn't moving. So what's going to happen here is when I turn this guy on, it's going to create waves. They'll go down the string, they'll hit that little pulley on that end, and they'll bounce back, and they'll interfere with each other. So this guy's going to keep making waves, and waves will bounce off of that end, and they'll interfere. Now they'll only make a standing wave at the right frequency. So what we're going to do here is we'll turn this guy on, and okay, so I'm starting with the frequency of 1. Alright, and so if I turn the amplitude all the way up, you should be able to see this little metal plate here moving. Y'all see that? Just moving up and down, up and down. How many waves is this making per second? 1. That's the frequency. It's making 1 wave per second. So this is the source of my waves. It creates the frequency. This is the medium, this string here. Now before I get started here, I need a volunteer. Thank you for volunteering. I need you to touch this string and verify that it's just one string.
It's one string.
Are you sure?
Yeah.
Be 100% sure. Okay, thank you. May return from whence you came. Alright, now, I'm going to increase this frequency, and I'm going to start with what we call the fundamental. It's the lowest frequency standing wave that you can make. And so for this one, it's about 4.9. So let me switch this to 4.9. So here, that seems all right. It's a little bit more now. It's got to stretch out. So it's about 5.1 now. So here, basically what's happening here is it's making a little more than 5 waves every second that are traveling down the string, hitting the pulley, coming back and interfering with each other. So if I've got this right, it kind of looks like a big jump rope. What do y'all think? I'm kind of moving together there. Alright? Not terribly remarkable, but the fundamental is where you have either a crest or a trough, or a compression or rarefaction, if you're talking about those types of waves. So here, the wavelength wouldn't be the length of the string. It would actually be twice the length of the string because you need a crest and a trough to make a whole wave. But just like we did with the wave table over here, I was able to make the wavelength shorter. How did I do that? Increase the frequency. So I'm going to increase the frequency, so I'm going to roughly double what I have here. So what's 5 times 2? Oh, there's a nice standing wave. Okay. So is it 4.9? So it's 10.2. Okay, so it's about 5.1. So here, now I have one full standing wave. Do y'all see that?
Yeah.
So this is vibrating up and down about 10 times per second. They're going down to that end, bouncing back, and they're creating this. In this area, we have constructive interference. In this area here, we have destructive interference. Do y'all see that? What do you call these big things? Y'all remember? Starts with A. Somebody whispered it. Antinode. So this is called an antinode. So then what is this guy? A node. So node means what? No vibration. Antinode means not no vibration, or maximum vibration. So how many antinodes do you count? Two. One there, one there. Everybody with me? How many nodes are there?
One.
We got one here, but what about...
Three.
Two.
You got one down at that end.
Three.
And technically there's one at that end. So you got three. Right? This is what we would call like a closed end resonator, because both of the ends will always make nodes. Right? So at 10.2, what's 10.2 times 2?
21.4.
Download that. I don't need all that extra noise. Now what do I have? How many waves are there?
4.
2 waves. Remember, I need a crest and a trough for 2 antinodes. See, do y'all see how it's weird to call this a crest and a trough? Because it's just, how many strings do I have here? 1. Are you sure about that? She proved it, right? So the trouble is when I start doing this, students think that they can stick their finger in there. Can you stick your finger in there?
Yeah.
No, it's just 1 string. You can't do that. All right. So here in a second, I'll let y'all come up here and poke it. Don't worry, it's not going to cut you. So here I've got 2 waves. How many antinodes do you see? 4. How many nodes are there? 5. So I doubled the frequency. So that means I got twice as many waves. So I got twice as many antinodes.
So if you did it at 40.8, it would be 8.
Okay, so 40.8. Y'all want to see? 40.8. Turn down to...
If you turn it up high enough, will they get small enough to where it's just one solid part again?
Yeah.
Do it.
Okay. Well, let's keep going up here. What's another 20.2? So that's 61? Are we still
I
there?
can barely see.
Barely. Right? So they're still there. So I can keep going higher. So what's another 20? So 62. Now some people say it's not vibrating, but if you look real close, you can see them. Now what's interesting here is we talked about sound, didn't we?
Yeah.
We said sound is a longitudinal wave, and we hear it by the air compressing and rarefacting. Well, last time I checked, here, let me go back to something y'all can see a little bit better. Can we see that?
Yeah.
Let's go back to 20. Alright, so we can see that, right? Everybody see that? Now this is a transverse wave, but it is moving up and down. So if there's air here, is it going to push that air out of the way when it moves up? Yeah. And it'll push the air out of the way when it moves down. And so it makes little compressions and rarefactions in the air. So theoretically you should be able to hear it. Can you hear this?
No.
No. You can't for several reasons. Number one, what is this? It's a string. Have you all ever seen an instrument made out of string? Uses strings to make the sound? What's an example? Guitar, what else? Violin, cello, piano, bass. All these things make harp sounds by strings vibrating. But what's interesting is, are any of them just pieces of string sitting there? No. Most of them have this other thing behind it. What is that other thing? You know what I'm talking about?
Kind of like a speaker.
Yeah. You've got like a guitar and it's got this body behind it. Well, the whole point of the body of the guitar is to amplify the sound that this is making. Okay? So that's the first reason why you can't really hear this, is we don't have anything to amplify it. The other reason why you can't hear it is because what is this frequency? 20.2. What is the range of human hearing? Do y'all recall? It's between about 20 and 20,000. So this is just barely inside the threshold of human hearing. Most people can't hear this frequency. And if you were to hear it, it would be one of the lowest bass sounds you've ever heard. Okay? But we can't hear it. So we can't really hear very well at this frequency. So if I increase the frequency, we should be able to hear it. Can anyone hear that? No, I can hear it, but y'all are close enough. What if I...
Yeah.
That's pretty cool.
And so remember, the pitch dictates the frequency. And so if you come up here and you touch the chord, you can feel it vibrating. Now how many times is it vibrating per second? 620. So it's kind of hard to see that. But it is vibrating that fast. Now it's very quiet because it doesn't have anything to amplify it. So what I'm going to do here is I'm going to go back down. I'm going to go further down, back down to 10.1. So we just get one wavelength here. So I want you to come up here and poke this thing.